Welcome back to the deep dive. We have quite a stack of updates today, and they all seem to center around one core theme: autonomy.
It really does feel that way.
We're seeing it everywhere in how code is being written, how enterprise data is getting managed, and, literally how robots are driving themselves across the surface of Mars.
It's a heavy lineup.
Right.
I think we're definitely moving past that, look what this chatbot can say phase and firmly into the look what this agent can do phase.
Right. It's action over just conversation.
Exactly.
So today we're going to break down Anthropic's new fast mode, which sounds great until you see the price tag. We'll also look at how Databricks is essentially letting AI build its own infrastructure.
And then there's the science roundup. Honestly, it feels like science fiction. We're talking vision restoration, giant phantom jellyfish.
It's incredible. And we'll wrap it all up with the toolkit, the actual software that's trending this week that you can use.
Sounds good.
Okay, let's start with the big one, Anthropic. They've launched this fast mode for Claude Opus 4.6. Now, I have to be honest, usually when a company says fast mode, my first thought is stupid mode.
Oh.
They just swap in a smaller model, distill it down, and hope you don't notice the reasoning got worse. Is that what's happening here?
Surprisingly, no. And that's actually why this is such a big deal. They are not swapping the model for like a haiku or a sonnet.
Oh, interesting.
This is the full frontier level Opus 4.6. Massive context window, high-level reasoning, the works. But it's optimized for extremely low latency.
How low are we talking?
They're claiming it's roughly 2.5 times faster than the standard Opus.
2.5 times is? That's massive for a model of that size. Opus is famously smart, but, kind of slow.
It is.
But you can't really cheat physics.
Yeah.
And you definitely can't cheat compute. So if the model's the same size, how are they speeding it up? Or, I guess, who's paying for that speed?
You hit the nail on the head. You're paying for it. This isn't some free efficiency update for everyone. It's rolling out as a sort of research-style preview. We're seeing it in GitHub Copilot right now, for example.
And the catch is the cost.
The catch is the cost. It's very premium. We're talking a price point that's roughly 6 times the baseline of the standard Opus.
6 times. That is a 600% markup.
Correct. And the cost can actually go even higher if you're using very, very large contexts.
Okay, so help me understand the economics of that. Why would a developer or a company pay a 600% markup just to save a few seconds? If I'm just generating a marketing email, I can wait 5 seconds. 10 seconds even.
Oh, absolutely. If you're generating an email, you definitely shouldn't use this. It would be a total waste of money.
Right.
But the target audience isn't the casual chatter. It is for latency-sensitive work.
Yeah.
Specifically, agentic coding. Think about a senior engineer deep in a flow state, debugging a huge, complex repository.
Okay, yeah. They have that entire mental map of the code in their head.
Exactly. And if they ask the AI for a refactor or a suggestion, and they have to sit there for 20 or 30 seconds, their mind wanders. They check Slack, they look at their phone.
The flow is broken.
The flow is completely broken. And recovering that context takes minutes, not seconds.
Yeah.
But if that answer comes back in near real time, they stay in the code. The argument is that the cost of breaking a senior developer's focus is way higher than the cost of the tokens.
That's a really fair point. It's the difference between a tool you wait for and a tool that keeps up with you. It changes the whole dynamic from, I asked a question to I'm jamming with the machine.
Precisely. And it's deeper than just a human waiting. Think about agentic workflows, where one AI triggers another, which triggers another. If you have a chain of 5 agents working on a problem and each one takes 30 seconds to think,
your whole application feels broken. Sluggish.
It does. But if you cut that latency down across the chain, suddenly the application feels live.
So it's really an infrastructure play. It's for the next generation of apps. If you want an agent to feel responsive, you have to pay the premium for this fast mode.
That's the bet they're making. It lets product teams offer a fast tier to their own customers that, actually works.
Speaking of infrastructure and making things actually work, let's pivot to Databricks. They're usually handling the heavy plumbing of the data world, but they've just released a new retrieval and agent stack that really caught my eye.
Yeah, specifically that instructed retriever.
Exactly. What is that?
It's a direct response to the biggest problem in enterprise AI right now, which is RJ.
Retrieval augmented generation.
Yeah.
A classic.
Right. And the standard way it works is, a user asks a question, the system does a keyword search in the company database, pastes those documents into the prompt, and the AI summarizes them.
Which is, it's classic garbage in, garbage out. If the search finds the wrong document because I used the wrong keyword, the AI just gives me a confident but totally wrong answer.
Exactly. Naive rag is terrible at nuance. If you ask, why did Q3 sales drop? A simple keyword search might just pull up the Q3 sales report.
Right.
It won't necessarily find the email chain from the supply chain manager explaining the shipping failure that caused the drop, because the words Q3 sales weren't in those emails.
So how is Databricks fixing that? How do you teach a search bar to understand context?
Well, the instructed retriever doesn't just match keywords. It tries to reason about the retrieval step itself. It looks at the user's intent and performs a multi-step retrieval across both structured data, like SQL tables, and unstructured data, like PDFs and emails.
So it's trying to understand the why behind the question before it goes hunting.
Pretty much. It's like sending a research assistant to the library instead of just using the catalog search bar. The assistant knows, oh, he's asking about sales, but I should probably check the supply chain logs too.
That's a great analogy. It connects the dots.
And the results are showing up in the usage data. Databricks released a stat that I actually had to double-check because it seemed so high. They reported that roughly 80% of new enterprise database branches or environments on their platform are now created by AI agents.
Wait, hold on a second. 80%.
80, yeah.
The agents are spinning up the databases.
The agents are creating the environments, yes.
That feels like a tipping point. We're not just using agents to query the data anymore. We're trusting them to build the house the data lives in.
And that's what positions Databricks as the governance layer. If you have agents touching production data, creating environments, you need a very, very secure sandbox. Databricks is saying, we are that sandbox.
It's moving us from toy chatbots to basically agents as actual employees with permission level.
And that's fascinating, but also a little terrifying from a security standpoint. You really have to trust that instructed retriever isn't hallucinating permissions or deleting the wrong table.
Which is why the evaluation-friendly part of their announcement is so key. You need to be able to audit the agent's logic. See why it did what it did.
You absolutely do.
Okay, let's shift gears a bit. We've been talking about digital brains and fast code, but I want to slow it down and look at the physical world. The science news this week is, well, it's profound.
It really is a good week for a bit of wonder.
Let's start with the deep ocean, the giant phantom jelly. I mean, even the name sounds like something from a Victorian horror novel. Stygiomedusa gigantea.
It's a fitting name. This creature is it's massive. We're talking about a bell of the head part that's huge, maybe a meter wide. But the oral arms, which function like tentacles, can stretch 30 feet long.
30 feet?
Imagine a creature the size of a school bus just drifting in the dark.
And the craziest part is, this isn't a new species, is it? We've known about it since 1899.
We knew it existed, but barely. It's been a ghost. For over a century, we basically just had damaged specimens that got brought up in nets, or these fleeting glimpses.
But not anymore.
Researchers off the coast of Argentina, in Patagonian waters, finally captured extensive footage of it in its natural habitat.
Why has been so hard to find? Is it just the depth?
It's depth and just. Density, the ocean is incomprehensibly large. Even a 30-foot jellyfish is a needle in a haystack down there. Seeing it waddling, that's how they described its movement, gives us biological data we've never had.
It's a good reminder that we've mapped Mars better than we've mapped our own oceans.
It really is.
Speaking of mapping biological mysteries, let's talk about vision. Life Biosciences got FDA clearance for a therapy called ER100. And this isn't just, take a pill to slow down glaucoma, is it?
No, this is entirely different. Traditional medicine is usually about maintenance. You have damage, so we try to stop it from getting worse. ER100 is based on the concept of cellular rejuvenation.
You mean literally making the cells younger?
Yes. It's a gene therapy. It targets the retinal ganglion cells, those are the ones that die off in glaucoma, and it triggers a mechanism to reset their biological clock. It's based on epigenetic reprogramming.
Okay, explain that simply. I think people hear gene therapy and epigenetics and their eyes just glaze over.
Think of a cell like a computer. When it's new, the software runs perfectly. Over time, it gets buggy, settings get changed, errors accumulate, and it slows down. That's aging. This therapy is like hitting restore to factory settings.
So it doesn't change the hardware, the DNA is the same.
Exactly. It just resets the software, the epigenome, to a youthful state.
That's wild. So if this works in the eye?
Then the door opens for everything else. The eye is just the testing ground because it's a contained system. If you can reset the age of a neuron in the eye, can you reset a kidney cell, a heart cell.
You're attacking the root cause, which is aging itself, not just the symptoms.
That's the idea.
It's incredibly hopeful. But let's look at a slightly more vanity-focused application of aging tech, a hair loss cap.
Yes, a bit of a pivot from curing blindness, but the tech is interesting. This is from researchers in Korea. We've seen those red light helmets before, right?
Yeah, they look like bicycle helmets with glowing LEDs inside. You see them in the back of airline magazines.
This one uses a wearable OLED array with near-infrared light. The claim is that because it's OLED, it conforms better to the scalp and delivers more consistent photobiomodulation.
And the results. Because usually these things have pretty marginal gains.
Well, in lab tests, they claimed it suppressed hair follicle aging by 92%.
92.
That's the number. Now, we always have to be skeptical of lab tests versus the real world, but that is significantly higher than traditional LED therapies. The idea is to offer a non-chemical alternative, since a lot of people avoid drugs like finasteride because of side effects.
I'm sure there's a massive market just waiting for that. If it works, they won't be able to keep them on the shelves.
Probably not.
All right, finally, let's leave the planet entirely. Mars. The Perseverance rover just did something historically significant.
It went for a drive. But this wasn't just any drive. It was an AI-planned drive.
Now, people might not realize, usually, there's a person in Pasadena with a joystick, metaphorically, telling the rover exactly where to go, right?
Sort of. Usually, engineers on Earth look at the pictures, they map out a safe path, upload the commands, and the rover just executes them blindly. Move forward 2 meters, turn left 10 degrees. It's very slow.
But Perseverance just went on its own.
It used onboard vision language models to look at the terrain itself. It identified hazards, boulders, sand traps, steep slopes, and it charted its own path to the destination. It made the decisions.
Why is that so critical? I mean, why not just keep driving it from Earth?
It's the light speed delay. A signal can take up to 22 minutes to get to Mars. So round trip is 45 minutes. If the rover starts sliding into a crater, you can't hit the brakes. By the time you even see the problem, the rover has been dead for 20 minutes.
So for real exploration, the robot has to be smart?
It has to be. If we're going to explore Europa or the moons of Saturn, where the delay is even longer, we can't micromanage. We need true autonomy. This drive proves the rover can understand its environment well enough to keep itself safe.
It's amazing. We have agents writing code, agents building databases, and agents driving on another planet. The human is moving further and further up the management chain.
That really is the trend of the decade.
Yeah.
We're becoming the orchestrators, not the operators.
All right, let's bring it back down to Earth and look at the tools you can actually use today. We've got a list of trending AI utilities making waves. First up, Supaboard.
This one is for anyone who hates SQL. Supaboard connects to your data, but it lets you ask questions in just plain English. Show me the churn rate for last November. It handles the query generation for you.
Very useful. Next, we see Claude Opus 4.6 again, but listed specifically as a tool here.
Right, this just reinforces what we talked about. It's becoming the default brain for agentic tasks. If you're building a tool that needs to reason, you're probably plugging this API in. It's the engine under the hood.
Then there is moltbook, lowercase m, a social network for AI agents.
It sounds bizarre, but it's actually pretty logical. If agents are going to collaborate, they need a discovery protocol. They need a place to meet and exchange capabilities. Moltbook is trying to be that directory.
So my scheduling agent can go to moltbook, find a travel agent, and book my flight without me.
That's the vision. It's like LinkedIn for bots.
Next up is CreateOS.
This is all about unification. Right now, you might generate code in ChatGPT or Cursor or Claude. CreateOS is a platform to deploy that code into a live app from a single place. It's the save and publish button for this new AI coding era.
We also have Atoms.
Atoms is more focused on the execution side, turning ideas into products that actually sell. It's less about the code and more about product market fit. It helps you figure out if your idea is really a business.
And Hugo for customer support.
The big headline for Hugo is the business model. Most AI support tools charge per ticket, like $1 per resolved chat. Hugo avoids that. For a high-volume business, that usage-based pricing can be a killer, so Hugo is trying to disrupt with a flat rate.
Smart. Then we have findable with a dot at the end.
This is SEO for the AI age. We're calling it GEO, Generative Engine Optimization. It helps make sure that when someone asks ChatGPT about the best running shoes, your running shoes show up in the answer.
That's going to be a massive industry. If you aren't in the training data, you don't exist. And finally, Codex by OpenAI.
The command center. This is the hub for orchestrating agents. It's OpenAI's play to be the operating system for all these different agentic workflows.
It really feels like the toolkit for the modern builder is changing every single week.
It is. The barrier to entry for building complex systems is just dropping so rapidly. You don't need to know how to write the SQL or optimize the neural net anymore. You just need to know how to orchestrate the agents that do.
And that brings us to the end of this deep dive. We've covered a lot, from the economics of fast coding to the biology of deep sea giants.
It has been a pretty wide-ranging one.
So here's a thought to leave you with. We talked about agents building databases and rovers driving themselves. At what point does the human in the loop become the human in the way? As these systems get faster, like that 2.5x speed boost from Anthropic, our ability to supervise them in real time is disappearing. We're going to have to start trusting the math.
That's the scary and exciting part, isn't it? We're handing over the keys.
If you enjoyed this analysis, please follow the show and maybe share it with that colleague who is still doing manual SQL queries. They need to hear about Supaboard.
It really does help us out.
Thank you for listening. See you in the next episode.